We want to find the distance from a point to a plane by using a projection. So let us consider the geometry. We're starting with a plane, and we have a point P. What do we need to consider here? We need to consider the normal vector for the plane. Now, if we can get the normal vector going through the point P, that would certainly be helpful. So if this is a version of the normal vector, some multiplier of the normal vector, maybe we'll make it bigger for the sake of our discussion. Let's call this the normal vector, n. And we can see from our example here that the normal vector for the plane will be 2, -3, 4. How do we find a vector that we can project onto n so that we can find the distance? I have the point P here. I'll need to pick another point on the plane. Any point will do. I pick this point Q, and I can construct the vector QP. Now, the distance from Q to P is unlikely to be the shortest distance. So we construct this vector QP. Probably not the shortest distance, but if I project QP onto n, do we see how that new vector here, which will be the projection of QP onto n, that its length should be the distance from the point to the plane. That shortest distance is on a perpendicular relationship. So what do I have to do? I have my point P. My point P is 3, 4, -5. Can't I find a point Q? So looking at this equation, I have 2x minus 3y plus 4z equals -10. Can I easily find a point on that plane? And I argue that the obvious one is simply -5, 0, 0. We see that 2 times -5 is -10, -3 times 0 is 0, 4 times 0 is 0. So I'm going to call that point Q. So I have point Q is -5, 0, 0. And I have point P is 3, 4, -5. And I do not think the distance from Q to P is the shortest distance from the point to the plane. Seems unlikely. But I can construct that vector QP that I'm going to choose to project onto n to get that distance. So what is vector QP? In the x direction, from -5 to 3 is up 8. From 0 to 4 is up 4. From 0 to -5 is down 5. And we have our n vector. Our n vector is what? Our n vector is 2, -3, 4. But looking at our picture, the distance is going to be defined by the projection of QP onto n. So let's find that. What is the projection of QP onto n? What's our formula? QP dot n over n dot n times n. QP dot n over n dot n. What is QP dot n? What are we going to get here? QP dot n, 8 times 2 is 16. Plus 4 times -3 is -12. Plus -5 times 4 is -20. Over n dot n, 2 times 2 is 4. Plus -3 times -3 is 9. Plus 4 times 4 is 16. Times n, which is 2, -3, 4. So what do we get here? We get the projection of QP onto n equals what? 16 minus 12 is 4. Minus 20 is negative 16 over 29 times 2, negative 3, 4. So that is the projection of QP onto N, but the distance, looking at that picture, the distance from the point P to the plane is going to be the magnitude of the projection of QP onto N. Magnitude of the projection of QP onto N. That's what we need to find. So we have the projection of QP onto N. How do I find its magnitude? Let's go ahead and do that. So the magnitude of that projection is the magnitude of all of this stuff. So we can pull this out as the absolute value of negative 16 over 29 times the magnitude of 2, negative 3, 4. So what do we get? We get 16 over 29 times the square root of what? 2 times 2 is 4. Negative 3 times negative 3 is 9. 4 times 4 is 16. So I get 16 over 29 times the square root of 29, or if you like, we can go ahead and say simply 16 divided by the square root of 29. And that indeed will be the distance from the point to the plane.